So in this video, we're going to see one more example on loop invariant. So we are going to study loop invariants, and the only difference, at least in this problem, is going to be that you're going to look at a problem that involves arrays list. Okay, so on the previous problem, we worked on something that did not really take in a list as an input, but we still used loop invariant, and on just a slight change here, we're just going to work with something that actually not takes in a list here. So the problem is very simple. The problem is given a list of some kind, let's say a list, more specifically a list of integers. So given some list here, given some list A, that happens to be a list of integers, my question here is, write me a function that finds the maximum element in that entire list. So it's a very straightforward problem given some list A. Let's say A in this case is this list. So let's just make a list of just maybe 4 elements here, and let's just put in some values. So let's say this happens to have a value of 4, this has a value of 1, then I've got 10, and let's say I've got -1. And your function is just supposed to return back the maximum in the list A, and your answer is going to be, in this case, the value, the integer 10. It is going to return back to me 10. I do not want the index here. Let's just say I want the actual value that happens to be at that index. So you return back the value 10 to me. Okay. So how would I do this? How would I set up my problem here? And more specifically, can I actually use loop invariants to do this? Sure, absolutely. This is not going to be a recursion solution. I'm going to use this using non-recursion. I'm going to frame my solution using an iterative solution where I'm going to build up a loop, and instead of just building the loop kind of in a semi-random approach, I'm going to be a little bit more specific as to what my loop invariant is, and using the help of the loop invariant, I'm going to formulate my solution. So to do this, what I'm going to propose now is let's just create this array A, but let's just make it a little bit more general. So let's say I've got this array A again here. So this is my array A, and what I'm going to do now is, let's just assume that, you know what, we have already visited this portion. Everything in blue has been visited, meaning I've already looked at this portion of my list. Everything in blue has already been looked at, and because I've already looked at this blue portion of my list here, the maximum element that I have at this point, whatever is the maximum element that I have at this point, is going to be stored in this variable max here. Okay, so let's just create let's just do max. Let's just create a local variable max here, that as of now, whatever that list has been traversed of this blue portion, whatever the max is in this blue portion, is inside the variable max. So what's the idea? How would I get the max of the entire list here? Well, to get the max of the entire list here, I would like to have this entire list in yellow to be covered in the blue region, because only when the entire list has been traversed, then max at that point would contain that value which is of that portion of the list that is in blue, and if the entire list has been traversed, meaning everything is in blue, then max should contain the maximum of the entire list in yellow here. Okay, so let's be a little bit more specific now. So given this, let's just say that the portion of the list that hasn't been traversed yet, the starting portion of that list that hasn't been traversed yet, let's just call it I. Okay, so I is just the start of this position of the list that hasn't yet been looked at. Okay, or in other words, everything up to 0 to I minus 1 has been looked at, right? And max is the max of that list from 0 to I minus 1 here. Okay, so given this now, let's write a function. So let's go to Python here, and let's just put up some kind of a solution here. So I'm just going to say in this case def, and let's just say let's just come up with a decent function name. So let's say max in and list. Okay, that takes in as an input my list A. And what I'm going to do now is I'm just going to find out whatever is the max in listing. So if I just want to be a little bit strict with my precondition, let's assume that I at least have one element. I just have at least one element in my A to begin with. Okay, so what would if this is the general idea? If this is general idea here, what would my loop invariant be just before? So let's do this. So let's say I'm going to write some code here. Somewhere in my code, I'm going to put up my loop at some point, and after I put up my loop here, I'm going to at some point do a return of some max element. So before my loop begins, so let's say somewhere over here I've got my loop. Okay, so let's say I've got some place over here. I'm going to start my loop. So let's just create as my actual loop. Okay, so this is my loop over here at some point, and just before my loop begins, I need to guarantee that at least just before the loop begins, my loop invariant, whatever my loop invariant is, should be true. Just after the while statement of my loop, meaning if this piece in blue, so again, let me just be a little bit consistent here. So let's do this. That's the body. Let's just assume that this piece, this blue box over here, is the body of my loop. And what I have here is my start of my while loop. Okay, some condition there, and this over here is some return statement. So let's just go back to my return statement, where I return back whatever is the max element that I found. So just to be consistent, so calling this max, let's call this max element. Okay, I'm just going to return back some kind of a max element from this function. And what are the places, what are the various points in my code that a loop invariant, whatever loop invariant that I'm proposing here, this is my loop invariant here. So again, this piece over here, what I've done here is kind of semi-formally, this is my loop invariant. Now again, I'm doing this via pictures here, but you could even be a little bit more formal there. But I just believe that the picture is going to make a little bit more, give us a little bit more clarity in terms of how I'm going to frame my solution here, and what are the various places that the loop invariant must hold. So one of the places it must hold is this place just before the while loop, this place 1 right there. The other place is just after the while loop, meaning just before the start of the body and just after the while loop. Okay, it's just a point. I'm just going to create a point where it must hold just before the body of the loop starts executing. The third point is just after the body of my while loop, and at some point the while loop should terminate. My loop must come to a conclusion, must come to a termination point. So this is, it's again, just to recap, this is my point 3, at which point when the while loop terminates, just before the return statement executes, I could say that's my point 4, that the loop invariant must also be true. So if my loop invariant is true at 1, 2, 3, and 4, well, at least I know that my while loop is working correctly. So given this idea here, let's just frame our function now. So I'm just going to rewrite this on the other side here, and I'm just going to say def of max list max in okay. And again, what I'm saying here is that at least I should have one element in my list A to begin with. If I don't have anything in my A, if my A is empty to begin with, I do not have any max element. In which case, maybe I should be throwing back an exception and raising an exception. But let's just make a precondition that at least I have one element in A to begin with. Okay, so what would the loop invariant, like, what should I write over here? What should this code be in this space here? What should the code be in this space here so that my loop invariant at 1 is true? Now my loop invariant over here, again, just to recap here, it just says that whatever is this blue portion, whatever is the list that I've already looked at, right? From that looked at list, max element is going to contain the max of the portion to the list in blue that has already been looked at. Okay, so why don't I do this? Why don't I just take my list again, which this is a list, and just generalize it for the very first time before the loop begins by saying that look, the only portion of the list that I have looked at so far is at index value 0. Everything up to the value at index 0 has already been looked at. Okay, if this has been looked at, and everything after that, meaning everything starting from 1, everything starting at index value 1 hasn't been looked at yet. So what's the max going to be then? Well, max element, if you've only looked at one element in the list, the max element is going to be that element itself, right? So does this give me enough? Do I have enough material now just to fill up everything in this yellow space here, just before the start of my while loop? So let's do that. Let's just say at this point I can just quickly say uh, my max element, my max element is going to be equal to whatever is a of 0. Okay. All right, great. So I know that this is a max element. That's the initialization. Max element is going to be equal to a of 0. What is I going to be equal to? Well, I is going to point to that portion of the list that hasn't yet been looked at. What is that portion of the list that hasn't yet been looked at? Well, it's starting from I equals to 1 because I equals to, well, in this case 0. The index value 0 has already been looked at. I've already done that and I've already got the max element. So if I at this point should be equal to 1. Okay, let's just ensure that we have already, does my loop invariant hold at this point 1? It holds at 1 because after that I'm going to just start my loop. So if I'm just going to be consistent with my colors, so this is my start of my while loop. Okay, and at 1, just before the while loop, meaning just at this space, my loop invariant holds because max element is this value of a of 0, and everything after 0, whatever is this index value 1 hasn't yet been looked at, and I should be pointing at that portion of the list that is still remaining to be looked at. That's where I is currently pointing at. So that's good. I've already got my initial variable set up correctly. Now the question here is, what should I? The first thing is what goes inside the what goes inside my a Boolean expression of my while loop, and the second part is what goes inside the body of my while loop. Okay, so what I'm going to say now is that inside the Boolean condition, what I'm going to put there is how long should this I keep on traversing? Like, what is the idea with the I here? Where should I be before I know that I've looked at the entire list? What I really know at this point is that I cannot be the last element. I cannot make I as that portion there. Because if I is this last index of my list, what that means from my loop invariant is that everything before I has been looked at. If everything before I has been looked at, meaning the blue portion of the list at this point would be all of everything up to that piece, meaning whatever I is currently at hasn't yet been looked at. And who knows, the worst case scenario could be that the maximum element of that list would be at that last index position. So I is something that must be at 1 after, meaning I should be right at this new position, just to show you that just going beyond the boundary of my list here, meaning I should be at this right here. This is the correct position of I. If this is where I is currently pointing at, then the entire blue portion, as per my loop invariant, would consume the entire list A. So what is that value of I? Well, I in this case should go everything up to, keep on running this loop, everything as long as I is less than length of A. Okay. Okay, so this is the body of my loop. As the body of loop, somewhere in the last statement, I'm just going to say I plus plus. Okay, Does this loop terminate? Does this loop terminate? What would I be when this loop terminates? Well, the condition says that keep on running the loop as long as I is less than length of a. I will only terminate. I'll only terminate when I, at this point, just after when the loop breaks, just after when the loop terminates. At this point, just after it terminates, I at that point is going to be I is going to be equal to length of a. That's good because that's exactly what I must be. I must be the length of a. This position over here is length of a minus 1, right? This index position right there. This index position is length of a minus 1, right? This is length of a minus 1, and I know that I shouldn't be at that position. I should be 1 after that, meaning this is the right position of I. So this guarantees, just by looking at this code so far, I know that the loop will only break only and only if when I equals the length of a, so far with the way I have actually framed it, I plus plus. Okay, so now what is it I should do in the body of the loop? What is that I should do in the body of the loop so that my loop invariant holds at this point at point 2. It also holds at point 3 just after the body of the loop, and it holds at point 4 just after the loop terminates. Okay, so inside the body of the loop, the way I'm going to frame my solution now is, let's just use blue here. So I'm going to say if a of I happens to be greater than max element. Okay, so what I'm saying is, if this is the I I'm currently looking at, okay, if this is I am currently looking at, okay, this is what I'm currently exploring, this is the value I'm currently looking at. If this value I'm currently looking at happens to be greater than the max I've already found in that region, again, blue isn't a good color yet, but it becomes confusing to see in that with all that blue that I have on my figure here. So let's just put pink here. Okay, so if this is in this pink region, if the best that I have is in this max element, and this is what I'm currently looking at, if this is what I'm currently looking at, what I'm currently looking at happens to be best than what I have got previously, okay, in which case it's time to update the best. So the best was max element previously, but now the max element has a newer value, and the newer value is going to be a of I. All right, and then I've got I plus plus, and after this loop breaks, what should I do? Well, I just have to return back the max element. So I'm just going to say return max element, and this is all that is there to doing this problem. I mean, it's as straightforward as that. The moment I had my loop invariant set up, I just use the help of my loop invariant in getting this solution completely articulated. Okay, so what we'll do is just in the next video, just to wrap this problem up, we'll just work through a small use case and see if I can actually find the max element, just working through this code base.